Hey guys, welcome to Code Streak Daily. In this video, we tackle the LeetCode problem, minimum add to make the parenthesis valid, and it is a medium level difficulty problem. So let's go through the problem description. A parenthesis string is valid if and only if, okay, there are certain conditions given here. It is the empty string and it can be written as AB, A concatenated with B, where A and B are valid strings, or it can be written as A, where A is a valid string and you are given a parenthesis string s. In one move you can insert a parenthesis at any position of the string. For example, okay, there is a string parenthesis given, you can insert an opening parenthesis or at the start, or a closing parenthesis to be, we can insert a closing parenthesis, and we have to return the minimum number of moves required to make this s string valid. So here we have a string s, and here there are certain parentheses. Here we have one opening parenthesis and there are two closing parentheses. So let me write here. Here I have one opening parenthesis and there are two closing parentheses. So basically these two parentheses make a set, and this is an extra parenthesis that is being closed. So to make this string or this parenthesis valid, we need to add another opening parenthesis here. So if I add an opening parenthesis here, there are two pairs of complete parentheses here. So it makes a perfect string. And for example 2, here I have, there are three opening parentheses and there are no closing parentheses. To make this complete, I need three closing parentheses. So if I put three closing parentheses, it makes a complete set or three pairs. So I have to return minimum number of moves required to make this string valid. Okay, now let me reset this. Now let me give some idea how to do this problem. So we need to initialize two counters. I'm taking two counters as one is open and one is closed. To and open is used to track the unmatched opening parenthesis, and close is used to track the unmatched closing parenthesis. Then we have to loop through each character in the string, and if we encounter or if we get an encounter with an opening parenthesis, then we are going to increment the open counter, and if we encounter a closing parenthesis, then we will be checking certain conditions. Here we have to check if there is an unmatched, or that means if there is an open parenthesis already, then we have to decrement the open parenthesis, indicating that we have found a match. If there isn't any opening parenthesis, then we are going to increment the close counter. Then we are going to uh, return the sum of both open and close counters, which represent the total number of moves required to make the string valid. So let me write the code for you and I'll explain it. So here I am taking open and close both counters here. Open and close both the counters I am taking here. Now I am writing a for loop for char in s. If char double equals an opening parenthesis, then I'm just incrementing the open by 1. I'm checking that if char double equals a closing parenthesis, then I have to check that if there are already any opening parenthesis there or not. So if open is greater than 0, then it means that there are some opening parenthesis already there. Then I have to decrement the value by 1. It means that I have found a pair of closing parenthesis for an opening parenthesis already. So I'm just decrementing the value of open by 1. If there are no opening parenthesis, then I'm just incrementing the close value by 1. So after traversing through the complete string, I have to return both the sum of both uh, open and close. That's it. So this returns the total number or minimum number of operations required to make the string valid. Okay. Now let me run the code once and see if we can pass all the test cases or not. Yeah, our code successfully passes the public test cases here. Now Let me submit the code and check if all the hidden test cases will be passed or not. Yes. After I submit the code, all the hidden test cases are being passed, and we have a runtime of 40 milliseconds, and it beats the 20.46% of users. That's okay. That's good. We can also write some more efficient code also. So if you are able to write some more efficient code better than this code, please do put that in the comments of this video. And this solution runs in order of n time complexity, where n is the length of the input string, and it takes a space complexity of order of 1. So it is making a suitable for large inputs also. Don't forget to subscribe this channel and hit the bell icon to get the daily updates about the Geeks for Geeks, and as well as the LeetCode daily solving problems. And hit like, comment and share this video. Thank you.